Hello viewers, in this video we will learn about the relative humidity. See, here I can explain you the relative humidity in a single line definition, but that is insufficient to understand its function in psychrometric. You will undoubtedly experience a 10-second period of freezing if you attempt to solve a problem involving relative humidity when you do not have a complete understanding of its function. Here is the definition. It simply states that you can identify the necessary amount to saturate the air at the same temperature by expressing the amount of moisture present in the air as a percentage value. Here, saturation means it's enough or overload. There is no more place to accept some more content in it. If you try to add some more, it will automatically come out of that particular object. Okay, I will elaborate you with some example. Here I have drawn a tumbler with a capacity of 100 ml. That means you can't even add another ml of water after the first 100 ml. If you do that, it will come out of the tumbler. See, I simply add 90 ml of water to it. Now tell me, is it correct that I can add another 10 ml to saturate the tumbler? Yes, it is correct. If I add 10 more ml to the tumbler, it will saturate. And one more tumbler is zone and it contains 40 ml of water. Here you need exact 60 ml of water to saturate the tumbler, right? Yes. The tumbler is seen here with a capacity of 100%. I don't care how much capacity it is to hold water. It may be 100 ml, 1 liter, 10 liter or something completely else. I am merely going to use its entire water holding capacity as 100%. And I am going to fill it with 90% of water now. As a result, the tumbler has a relative humidity level of 90% and I need to add 10% of water to make it saturated. Here is another example of vessel that contains 40% of relative humidity and required 60% more to become saturated. Now we will go on to the next step. But before proceeding that, consider the tumbler as a dry bulb temperature and the sky blue line over the surface of water as a wet bulb temperature and the water as a moisture. You can see in the previous slides how adding or removing water changes the relative humidity. In addition, we will investigate whether there is a change in relative humidity with temperature changes using psychrometric chart. Here I took a tumbler and filled it with water. As I previously said, consider the tumbler to be a dry bulb temperature and the water surface to be a wet bulb temperature. Simply plot the given data in psychrometric chart. I plotted with 30 degrees Celsius dry bulb temperature and 20 degrees Celsius as a wet bulb temperature, resulting in the relative humidity is 40%. In addition, the specific humidity is a 10 gram. Okay, look at the tumbler, the relative humidity is 40%. Hence, you need exact 60% of moisture to saturate the air at same temperature. But I don't want to modify the specific humidity. At the same time, I need to adjust the relative humidity. Let's have a look at how to accomplish this. Here is the first case. As I stated, I don't want to change the specific humidity 10 gram. I have plotted 10 gram of specific humidity and 35 degrees Celsius as a dry bulb temperature. As a result, the relative humidity is 30%. Have you understand why the relative humidity changes without changing the specific humidity? See, I have increased the size of the tumbler, which has resulted in an increase in its water holding capacity. See, you can compare the current slide to the previous slides, where we used a dry bulb at 30 degrees Celsius and here we used it as a 35 degrees Celsius. Hence, the moisture holding capacity of the air is increased. In the final case, I need to achieve a relative humidity level of 100% without adding moisture. Simply pause the video and consider yourself how to accomplish that. I hope you get after watching this. Here I am just adjusting the tumbler size so that I can achieve a humidity level of 100%, where you can observe the psychrometric and plot the values 50 degrees Celsius in dry bulb and 50 degrees Celsius in wet bulb, resulting in 100% relative humidity. And you can see no changes in the specific humidity 10 gram. Here I decreased the temperature, by the way the water holding capacity also decreased as much as it able to hold up to 10 gram of moisture only. Finally, an example. You can observe the tumbler can hold 200 gram of moisture, but it only has 50 gram of moisture in it. Let's take a look at how much the relative humidity is there. If 200 gram of moisture equals 100%, then 50 gram of moisture equals 25%, right? Yes, it is. I hope you have a good understanding of how relative humidity works. Relative humidity not only depends on the moisture, but it also depends on the temperature variation. As the temperature rises, moisture holding capacity of air rises as well. See, similarly, a tumbler capable of holding 250 gram of moisture, but it had the same 50 gram of moisture in it. The relative humidity is fluctuating now without changing the moisture. I hope you see why this is happening, and this is the formula for relative humidity. You can get the solution by substituting the appropriate value in it. Thank you.